Yeah, I told her, I'm like, I swear to God, you're going to know.
Yeah.
That's scary.
It scares me.
Chapter 5 has some of the most fun stuff ever in it. So, well, it's just fun. So, let's start by looking at, these are our old notes. Remember, we ended our old notes on page 56. And down at the bottom of the page are some basic trigonometric identities. Now, some of those you already know. So you already know that cosecant is the reciprocal of the sine, right? You already know that. Now, a couple that you may not have thought about are what are called the quotient identities. Now, I want you to think about this for a second. I want you to think about the fact that you already know that the tangent is opposite over adjacent, right? You already know that. You also know that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. These are things you already know. Well, what happens if you were to put sine over cosine? In other words, what if you made a quotient out of sine and cosine so that you had opposite over hypotenuse over adjacent over hypotenuse? Well, what happens? Yeah, if you invert and multiply this, don't the hypotenuse parts cancel out? And you are going to be left with opposite over adjacent, which is tangent. So sine over cosine is tangent. And likewise, cotangent is cosine over sine. All right, let's look at the next page. Now we have what are called the Pythagorean identities. These are huge. These are really important. Let's go back and think about our basic right triangle. We've called this many things like adjacent, whatever, but let's just call it x, because that is the x side. This is the y side, and let's call that the radius, as though we had a big circle here. We've called it hypotenuse, but we can also refer to it as the radius. Everybody in the room knows that x squared plus y squared is r squared. Absolute Pythagorean theorem. Well, if I took that equation and divided everything by r squared, then it would say literally x over r squared plus y over r squared equals 1. But now wait a minute, guys. What's x over r? That's cosine. So this is cosine squared. And when we write trigonometric functions, and we want to square them or cube them or something, we don't write it like this. And I think you can see for obvious reasons why we wouldn't write that. We don't know what's getting squared there. So you could put parentheses in, but to avoid that, we just put the squared right here. That means cosine squared. Plus, what's y over r?
Sine.
Sine squared equals 1. So we just verified, or just kind of derived, the first of the Pythagorean identities. Sine squared plus cosine squared is 1. Always, 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 that's big. Sine squared plus cosine squared is 1. Now, if I take that identity, and let's just say divide everything by cosine squared, now what does it say? 1 plus, sine over cosine, we just talked about this, sine over cosine is tangent. And what's 1 over cosine? C. So here's another of your Pythagorean identities. So this is really the main one. The other ones come from messing around with that one. But these, you are going to be amazed. I mean, I wish I could skip ahead about, I don't know, 6 months. Because you'll see when you start using your derivatives and your integrals in calculus class, the tangent and the secant are together because of this identity. Now, you do want to make sure that you recognize this identity in other forms. For example, if I were to subtract the tangent squared, then doesn't it say secant squared minus tangent squared is 1? So all of these things, this one might be sine squared equals 1 minus cosine squared. They appear in different forms, so you have to recognize them even if they're not in the actual order that they appear in your notes. Okay? Now, the other one, if I took our cosine squared plus sine squared equals 1 and divided everything by sine squared, do you see how I would get the other Pythagorean identity that's on there? Yeah. Okay, so those are called the Pythagorean identities. Now, this next group are called the co-function identities. You have already noticed that every function has a co-function, not a reciprocal. I'm not talking about a reciprocal, I'm talking about a co-function. So we have sine and we have cosine. These are not reciprocals, but they are sine and cosine. We have secant and cosecant, and we have tangent and cotangent. Now, what does it mean to be a co-function? Again, these are not reciprocals. You know what the reciprocals are. What it means is, if we look at, let's just look at our standard triangle here. And let's say this was 3, and this was 4, and this was 5. Is it true in that picture that the sine of theta is 3/5? Would that be a true statement? Yes. Now, I don't know how big this angle is right here, but I do know that these two add up to 90. These two are called complementary angles, complementary angles, and they add up to 90. So this one, whatever it is, 90 minus theta. Now look at that angle for a minute. Is the cosine of that angle also 3/5? Is the cosine of this angle also 3/5? That's what it means to be a co-function. The sine of 50 degrees is the same as the cosine of 40 degrees. So when you have complementary angles, angles that add up to 90, complementary, complementary angles, the sine and the cosine of those angles are equal. So the sine of 10 is the cosine of 80. Likewise, the secant of 5 is the cosecant of 85. You see what I'm saying? Yeah, so that's what it means to be a co-function. It means you have that complementary relationship. And then we have the odd-even identities that we've already talked about. We've already talked about the fact that who remembers which functions are even? There's only 2 of them that are even. Who remembers which 2 they are? Cosine and secant. Yeah, so cosine and secant are even. And what it means to be even is, if you take the cosine of a negative angle, it doesn't matter. That's just going to be the cosine of the angle. Take your calculator out. Pick cosine 30 and cosine negative 30, and they will be exactly the same. Aren't they?
Yes.
Yeah. They're even. Same thing as secant. Now, The other functions are odd. These guys are even. The other functions are odd. So what that means is, and I'm not going to write them all down, they're all written here for you, but what it means to be odd is that if you take the sign of a negative, it's going to change the output sign. So if you get the sign of negative 30, it will be the opposite of the sign of 30. Sign of 30 is 1/2. Sign negative 30 is negative 1/2. That's what it means to be odd. Now, the first part of chapter 5 is going to be using all those things basically to simplify expressions and to do my favorite thing, I think, in the whole wide math world, trig verifications, which is like proving in trigonometry, doing proofs in trigonometry. But I'll try to contain myself. We need to do a little review work first. So, I want you to keep these notes close by, okay? All these identities are things we're going to do. By the way, does anybody know what we mean by the word identity? I'm kind of throwing it out there when I say reciprocal identities, co-function identities. Anybody know what it means to be an identity? Well, kind of. An identity is a statement that's true for all values of the variable. So here's an example. If I said 2x plus 5 equals 4, that's an equation. We can solve that, but it's only going to be true if x is negative 1/2, right? If I put any other number in there, it won't be true. It is true, but only for one value of x or a specified number of x's. But what if I said this? That's an identity, because that's true no matter what. So when I say sine squared plus cosine squared is 1, that's true. I don't care if you're in degrees or radians. I don't care if you're using whole numbers, fractions. It makes no difference. Sine squared plus cosine squared is 1. Same angle. Sine squared of an angle plus cosine squared of that same angle is going to be 1. That's an identity. Okay, see the difference? All right. Now, the first couple of exercises here, are you watching a clock for lunch so I don't? It's 1 o'clock, or 12. 12 o'clock. All right, so let's look at this first problem. It's more of a review problem than anything else. It says the tangent of some angle is 5, and the cosine is positive, and your job is to find the sine and the cosine. We had some of these in the last unit. This is a review. Well, you know me, I love to draw pictures. Where am I going to draw this picture?
First quadrant 1.
Quadrant 1. Because in quadrant 1, can I have a tangent of positive 5 and have a positive cosine? Yep, that won't happen in any other quadrant. Can't have both of these in any other quadrant. So there it is. Hypotenuse would be root 26 by the Pythagorean theorem. And now we can answer our questions. Easy. Sine 5 over root 26. Cosine 1 over root 26. Easy as can be. The next one is a little bit trickier. A little bit trickier. It says the cosine is 0.34, and we're going to find the sine of theta minus pi over 2. Now, the reason I said this one's a little bit tricky is this is the first time you've thought about co-function identities. Did that pop into your head when you saw this 90 minus theta, theta minus 90 thing? Okay. However, what's wrong with this? This is a little bit off. What's wrong with it? It's in reverse. Because when we talk about co-functions, complementary angles, it's theta and 90 minus, right? So I'm going to go ahead and turn that around. Now I can do that if I factor out a -1. Would you agree with me that I can do that? I can turn this subtraction around as long as I factor out a -1. And I can think about that -1 as just a negative sign. And now I've got the sign of a negative. Now what do I know about the sign of a negative? The negative comes out in front. So this is negative sine pi over 2 minus theta. So I've done a bunch of arithmetic. Are you okay with that? And then here we did our odd. It's an odd. Okay. So this is really what I'm finding. My job was to find this, but I've rewritten it, so now I'm finding this. All right. Now, tell me what you know about the sine of pi over 2 minus theta. Just this right here. Just this right here. What does that equal? That equals cosine of theta. But the cosine of theta is 0.34. So would you agree this right here equals 0.34? But since that was backwards in the problem, I had to make it negative. So my answer will be negative 0.34, the opposite of 0.34. Little bit tricky. Okay, so first, I think the trickiest part is right here, recognizing that's backwards. So we have to fix it. But as soon as we fixed it, we had a negative, sign is odd, so we had to pull it out in front. And then this is what we were looking for. This is 0.34, so we ended up with negative 0.34. This is day 1. It's going to be a little confusing sometimes on day 1, but you'll get it. I have total confidence. All right, now we're on to our new notes page. Problem number 3. There's not supposed to be that parentheses at the end. I'm not sure why I did that, why that's there, not sure. So ignore that parentheses there, and it's a mistake. All right, now, take a look at that. The directions say simplify. What's your thought? Okay, now, Peter said divide by sine x to get rid of that. Now, when I divide, I have to divide like both sides, right? I mean, if I have a 6, I can't just divide it by 2 and say, oh, I don't have a 6 anymore, I have a 3. That doesn't work. Instead of dividing by sign, maybe I should factor it out. Yeah. So you have exactly the right idea, you just want to do the right math. So we're going to factor out a sign. What will I have left from this expression if I take out a sign? Sine squared plus bing, 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 your little identity radar going up, because what's sine squared plus cosine squared? 1. So this big ugly mess just simplified down into sine. And again, I'm thinking ahead, I'm thinking of your calculus experience. It is much easier to do stuff with sine like find the derivative, for example. Much easier with sine than it is to do this, right? So we always want to simplify if we can, and that's what we're practicing now. Oh, look at number 4. Simplify. So what do you think you might want to do first? Just think regular algebra. What would you do if you found an algebra problem that looked like this? What would you do? Foil? Foil? I think foiling's a great idea. So I have secant squared minus 1. Don't these cancel when I foil? It's like the difference of squares up there. Now, I have this huge advantage because I'm older than the hills and I've done lots of these problems. But when I see a secant squared and a 1 together, I immediately think about my Pythagorean identities. And there's one of them that has a secant squared and a 1 in it. It's 1 plus tangent squared is secant squared, right? That's one of my Pythagorean identities. You've got them right here, you're looking at them. They're going to be like your reference for the next few days. Now, what I have is secant squared minus 1. If I took this 1 and subtracted it over to the other side, would it say tangent squared equals secant squared minus 1? Well, so then I can take that secant squared minus 1 and change it into a tangent squared. Would you agree with that? Now I'm supposed to be simplifying. What do I know about tangent squared? It's sine squared over cosine squared. Because remember those quotient identities? Tangent is sine over cosine. So I'm going to think of this now as sine squared over cosine squared over sine squared over 1. What do I do when I divide fractions? So times 1 over sine squared. What happens? It's 1 over cosine squared, which is secant squared. Alright, so let's go back through those steps again. First thing we did was FOIL, and that gave us secant squared minus 1, which we recognized is equal to tangent squared. So then we had tangent squared over sine squared, or sine squared over cosine squared, which is tangent, over sine squared. So instead of dividing by sine squared, we multiplied by 1 over, and that left us with 1 over cosine, which is secant. Yeah, I have to love it when it all comes together like that. It's so great. All right, we're going to do one more, and then we'll go to lunch with number 5. Tess, was your hand up? It wasn't? Okay. Now, this isn't an equation, guys, so it's not like you're going to be multiplying both sides. Your job is to simplify this. So it's a fraction minus a fraction. It's a fraction minus a fraction. So what might we do if we have to subtract two fractions?
Try to get a common denominator.
Get a common denominator. And won't the common denominator be these two things? 1 minus sine and cosine. Won't that be my common denominator? So this one needs to be timesed by a cosine. I'm getting a common denominator. And this one needs to be timesed by a 1 minus sine.
Wait, couldn't you first, like when you see 1 minus sine x, couldn't you like, wouldn't that equal cosine?
I would totally love it if that were the case, but these are called the Pythagorean identities, and everything's got to be squared. You cannot change sines and cosines unless they're squared. If you had a 1 minus sine squared, absolutely that would be cosine squared. But the Pythagorean identities only work if they're squared. Okay? Only work. I wish it were the other, I mean, I wish they worked all the time. Life would be so much easier. Another thing, some of you might have been thinking about, hey, sine over cosine, that's tangent. It is. Here's the problem, and you can do that, absolutely wouldn't be wrong. Here's the issue I have with it. How many in the original problem, which is blue here, how many functions are already there? 2, sine and cosine. When you turn around and make this a tangent, now you've got 3, and your job is to simplify, right? So it's almost always, I'm not going to say always because there's no always, but it's almost always easier to keep it in sines and cosines than to be going off on tangents. If you want to change it, you can, but it may mean more steps for you in the end. All right, let's finish this so you go to lunch because you're all starving. So here, I've got my common denominator. What's going to be on the top? Here, cosine squared minus, all right, now I want you to be really careful here. This is a distributive, right? So it's going to be minus sine x plus sine squared. Oh! What do we have in the numerator? 1 minus sine. So our numerator is 1 minus sine because these two make a 1. Every time you see them, they make a 1. What? On the bottom is 1 minus sine times cosine. Now, do you notice anything about that? These will cancel. Kids, you can't cancel parts of a subtraction, like I couldn't cancel a sign out, but this whole quantity will cancel with this whole quantity, and leave me with what on the top? 1 over cosine, which is, so that whole mess that we started with boiled down to just secant. All right, except for those of you that are like, what? You know what? I need you back at 35, in your seats at 35. If you're a woman, stay around, we'll figure it out.